Okay, Anaki, we are going to go through last week's question. I gave two pictures, right, for y'all to do the work. Let me share my screen now. Okay. Can see or not? Let's wait a while. Yeah, can see now. Okay. Right. So if I were to go to this one. All right. Which one is easier, this question or the other one? I think Zenith, you will think that the first one is easier, right? Because just follow formula, ma. Most students will like these because it's like no need to won't go wrong one. You just follow formula, calculate accordingly. But for this one, right, then they will panic. How do I estimate the area? How do I get the exact area? Okay, so let's see how this is done. Now, Anaki, have you done this? I think you forgot. I look at your face, I think you forgot. But it's okay lah. Okay, we go through together. I don't scold you, okay? Because you have a lot of homework also. Right, so it was said, right? There is this brick. So this is the brick placed in different or at different angles lah. Okay, so they classify it as position A, position B, and position C. And then it weighs 30 newtons. Then they ask you which position, A, B, or C, does the brick have the smallest surface area? Okay, but it's not the entire surface area, it's the surface area in contact with the ground. All right, so quite simple. I think this is pretty straightforward. So if I calculate for position A, right, it's 10 times 5, very straightforward. Okay, and then position B, area will be 3 times 5, and that will be 15. And then for position C, 10 times 3, and we have 30. Okay, Sneha is here. Right? You got this, right? Okay, Anaki, you don't have it, it's okay. But you know how to get the surface area in contact?
Yes.
Okay, so you try again on your own lah. Okay, and then we go to part B. In which position, A, B, or C, does the brick exert the greatest pressure? Okay, show your working. All right, so let's try to be more hardworking. We are going to calculate pressure for all positions. So pressure equals to force over area, right? Okay, so force is 30 Newton. All right, and then the area here, now don't have to worry about conversion because now we are just trying to find out which one exert the greatest area, greatest pressure. So if you are going to calculate your area in, meter square, it's going to make your life miserable. All right, so we take this as 50 cm square. And what do we have here? 3 out of 5, 0.6. Okay, so we put this as Newton per meter square. It's okay to leave it this way. In case you're wondering, do I need to convert to SI unit? No worries, don't have to. Okay, Kiran is here. So if we were to look at position B, same amount of force, right? Exerted over the area of 15 cm square. This is 2 Newton per cm square. Hi, Sneha. Hi, Kiran. Okay, Kiran, did you do your work from last week?
Yes.
You sure or not? Take
Sure.
picture and send to me. Okay, like you just show me. You lift it up. Did you do on paper or something? Yeah, just show me very quickly. Yeah. Don't have. Did you do it
I
on
did it
paper?
online. No.
No, okay. But you know how to get the answer?
This was the homework shown last week, right?
That's right. You remember. Got hope, very good, you can remember. Okay, at least you're not blur blur. I'm happy. All right. So you finish all this, isn't it?
Yes.
Is it the same answer that you have?
It looks the same.
Like that, you're not looking at your answer. You tell me it looks the same. That means you don't have your answer with you now. Correct?
Yeah, I don't have it with me now.
Okay, then you take a
I'm trying to
screenshot.
access it.
Okay, you cannot access it now. You take a screenshot, then after that, after the lesson, you compare with your own answer. Now, Zenith, do you get the same working as me? Similar. Sneha, you didn't manage to get the questions, right? Yeah, so you take a screenshot now. Okay, so this is actually the question that we have from last week. So I actually did part A first, all right? And then I looked for the area for all positions. Then part B, I actually calculated pressure for all the positions. Okay, and then they want to find the greatest pressure. And it is the position B. Okay, why position B? Take note, force is actually the same for all cases, but then it is spread over the smallest area. Okay, so that's why, okay, that's why. Zenith, do you wear high heel shoe when you go out? Never. Have you tried before? Never try. You go and try. Okay, borrow your mother's one. I think should be able to fit. I mean, my daughter also wear my shoes. Then you try to go out with your parents, walk for one day. Then see how that feels. Your ankle will be so tired and painful, like aching all the way, and your feet will definitely feel very tired. Okay, so when I was teaching back in school, I like to wear very high heel shoe, when I was a young teacher. Okay, very, very high, right? Because I want to look taller. So that's what I did, but then I always suffer at the end of the day. Okay, because, all right, the smallest area here indicate highest pressure, right? Same thing, when I'm wearing the high heel shoe, actually I'm spreading my weight over a smaller area. That's why my feet are so tired. But if I were to change into my running shoes, then I will feel very shook, right? Yeah, so comfortable, no more pain. All right. Okay, so if I turn you to the next question, this person, Tina over here, this is her high heel shoe. Very good example. I just talked about mine, and then now the question is here. And then this is the normal kind of shoe that she will wear usually. So you might be wondering, how do I actually find the area? Okay, because you need to do the calculation. So whenever you see question like this, if it still come out, you need to tell yourself, always consider those tiny squares that are fully covered or more than half the square is covered. Can? So let's look at this row. That means this one we will consider. So my own preferred method is I will take my pencil and then I will put the tick. Okay, so I will then eventually count how many ticks I have. So I go row by row. It's more systematic this way. So this square counted also. But this and this I can ignore. All right. So this is also counted as well. Counted also. Okay. This one also. Yeah. Okay. So all these are counted. Then when I go to the last row here, only this one is considered because the other two did not cover half. Can, Zenith? This is how it's done. Okay. So over here, we start counting again. This one is only one here. Then we have 1, 2, 3. And then 1, 2, 3. Okay, this one is just one here. The rest can count or don't count? No need to count now, or half only. Okay, Haresh is here. You get how to do this already? Okay, all of you? Kiran also, So Kiran, you have done this, right? You tell me what's the next thing we need to do. Look at part A. Try to recall from your own memory. Okay, pressure exerted by shoe A.
Find the area of 1 square.
Uh-huh.
Multiplied by the number of squares that you have marked on.
Okay, those I have ticked, right? So, all right, let's see how many I have ticked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 tick squares over here. So this area of one tiny square, Kiran, how much is this? Or what is the area of this?
4 cm square.
Good, 4 cm square. If I multiply these by 4,
64.
very good. You can calculate like this. Really?
Yeah.
Hello.
That's very good. Okay. So what do I do next? You finish up part A. Hi, Haresh.
Oh, hello.
How come I don't get to see you today?
Oh, wait.
Okay. All right, Kiran. What is the formula I use to calculate? Kiran, you're trying to look for the formula,
I can't remember.
Okay, it's okay. Don't worry. If I go back to the previous question, okay, this is where, this part B is where I calculated the pressure exerted. Okay, so here I use 30 Newton divided by 50 cm squared. So 30 Newton refers to
Weight.
the weight, which is force. Okay, force, and then 50 cm square refers to area, isn't it? All right, so pressure is actually calculated using this formula, force over area. Okay, so let's look at this question. Finish this up. Okay, don't give up. You need to check first. You have found the area, right? Okay, so now you need to look for force in the question. Can you find any information that tells you the force exerted?
The force exerted by a force 300.
Good. You can identify, right? So 300 newtons. Okay, don't forget the unit divided by the area. What's the area here? You calculated 60.
4 cm square.
Very good. So use your calculator to complete this calculation. Now, Haresh, have you finished this work?
Oh, no.
You haven't, huh?
But I can still do it.
Yeah. You can still do it now. Of course, no problem.
Yeah.
Okay.
Oh, you want me to do it now?
You can do it now. Okay, while we wait for Kiran to give the answer. Kiran, you use your calculator already?
Yes.
Okay, tell me the answer.
4.69.
4.69. Is it rounded up or rounded
It's
down?
Rounded up.
Okay, so rounded up, that means we must put what? The curly equal, isn't it? Then we put as 3SF. Okay, thank you, Kiran. Can I understand this better now?
Yes.